We are using an awful lot of concrete. If we can lower the amount of cement that we are using in concrete, or if we can replace the cement by another type of binder, it's millions of tons of carbon dioxide that can be avoided in doing this.
Concrete is resource and carbon intensive. Concrete is made from gravel and sand, bound together with cement. Cement production emits most of the greenhouse gas emissions from concrete. On a journey to preserve nature and mitigate climate change, the city of Zurich pioneered the use of recycled concrete and low-carbon cement through its public procurement policy for buildings.
Before Zurich, there was no demand for recycled concrete. The municipality of Zurich, we were one of the first to apply recycled concrete in our buildings, and that was a very important step. Somebody had to do it for the first time. Somebody had to take the risks also. We first established a demand for this recycled concrete. We really have a huge demand for material.
Recycled concrete is like a normal concrete. It can be used nearly for every part in a building. Walls, slabs, even pillars. It has the same strength.
The people used recycled concrete in the construction of roads, for example. But it was never used before in the construction of buildings.
Main benefit of using recycled concrete is the protection of the environment.
In Switzerland, landscape is traditional heritage. If you need material from excavations, it always goes together with the destruction of landscape. Concrete is one of the main parts of urban waste.
The government can help, for instance, with the policy on recycling, with the public procurement for all those constructions where they are responsible.
Since the city of Zurich demands since about 20 years recycled concrete, concrete producers in the near or even in the wider area of Zurich who are willing to deliver concrete for the city's own buildings, they had to change their processes.
We invested in standardization processes. So we tried to establish recycled concrete as a part of an environmental standard. And we did try to do this with several studies we made. And these were all little steps that were very helpful to convince the community that this material can be used in the building sector. Sometimes it's the builder, sometimes it's the government. Best cases, they are both together, but someone has to drive these innovations forward.
Recycling norms will become stricter in the next years. So that means that the companies are driven towards recycling in different ways that will enable us to reduce the amount of waste that we produce and also reduce the amount of virgin materials that we need.
You have to get from somewhere the material, and if you don't take it out of the ground, you have to have a building available in the nearer area.
It takes also a lot of energy to destroy the concrete, prepare it for reuse.
If you minimize the transportation and you recycle on site directly, you can save also money and CO2.
The 2000 watt society, that's a political goal that we have since 2008. We are trying to ameliorate our consumption of energy, and in this context, of course, also the building sector plays an important role.
The main impact on carbon emissions in concrete is made by the cement. 90 to 95% of the CO2 emissions. So the City of Zurich demands low-carbon cements, like for example the cement type CEM3B. It's a slag sand cement that reduces the CO2 or greenhouse gas emissions about 30% compared to a standard cement.
In Switzerland, it is traditionally not used that much. We decided that we are going to do a mock-up that shows all the different qualities of cement. The aim of the mock-up is indeed to show that there is no difference in an aesthetical appearance.
To further mitigate emissions from concrete and save resources, innovations in cement types, the recycling of concrete and the reuse of concrete parts are under development.
One of the barriers we have for introducing the new non-traditional cements is the norms and standards that we have for concrete elements, especially for the load-bearing elements. We want a building to be safe, to be there for the next 50, maybe even 100 years. So we want it to be built in the best way possible.
To use new products, it's always a question of security, it's a question of innovation, and this has to come together actually.
We have several alternatives for the current Portland cement.
For some of the solutions, for instance slag or the use of metakaolin, which is a specific clay, or fly ash, for instance, we have already the norms, so we are ready. The problem is the availability of these materials. A possible way is to use other clays to obtain cementitious materials.
We developed quite a lot of technology. We did a smart crushing of the concrete, and we developed this smart crushing technology along with then the smart separation technology. Not only the gravel and the sand can be recycled, it also means saving on natural resources, but we can also recycle the cement.
The new binders, knowing the mechanical behavior and this durability performance, we can change the norm to take it into account. The norms are a key point for innovation.
The net zero for Zurich will be the next big goal. Recycling material will be one part, reuse will be another part.
We don't only have to work on the level of the material, but also on the level of the components. We are more and more thinking in building for disassembly and reassembly.
We need a lot of information. We need the research, academia, industry to develop ideas, to innovate, and to help us to reach these goals.
We see that the technology is there to have a huge reduction of carbon dioxide emissions. So don't tell me it's not possible. It really is possible, but we have to have the guts to do it.